Hello everyone, in this video we are going to solve part 5, 6 and 7 of exercise 9.5, and in this question you have to use a suitable identity to get the product. Means you have to multiply this with this, and instead of directly multiplying you have to use a suitable identity. And identities are basically the simplest way, or you can say the simplified way to solve these kind of questions. And there are certain identities which we can use to solve these kind of questions. And in this question, the best suitable identity is a minus b into a plus b is equals to a square minus b square. Here, this term, if I consider this 1.1 m as a and this 0.4 as b, so this is our a minus b and this is our a plus b. So this is same as this. So we know that this is equals to a square minus b square. So if you have any problem, or you can say if you want to know how this identity is formed, you can check our videos on fundamental. There we have explained how these entities are formed. Or in the previous video I have already discussed that how these identities are formed. Now in this case we are simply using, we don't need to multiply this. Instead we can substitute, or you can say we can equate this with this. So this value should be equals to, this value is equals to this, and this can be written as a square minus b square. So our a is 1.1 m whole square minus our b is 0.4 whole square. So if we are able to solve this, so we will get our answer. Now this is 1.1 square and m square. This is, if this is written as xp whole square, this power 2 means x is multiplied 2 times and again b also multiplied 2 times. So similarly here also, if this is 1.1 square, so it should be 1.1 whole square multiplied with m square minus this is 0.4 whole square. Now there are two ways of squaring 1.1. First, we multiply 11 with 11. 11 square, 1.1 square means 1.1 multiplied with 1.1. And we are removing the decimal right now. We just have to multiply 11 with 11, and 11 square we know that is equals to 121. Now we can count the decimal. This is 1 decimal and this is 2 decimal. We have to count the digit on the right hand side of the decimal. There are 2 digits, so we can count from the right hand side 1, 2, and we can place decimal right here. So 1.1 square, or you can say 1.1 raised to power 2 should be equals to 1.21 m square. There is another way. This is 1.1 whole square. We can remove the decimal and we can write it as 11 upon 10 whole square. Now 11 square is 121 and 10 square is 100, because we know that whenever there is two terms, or you can say two numbers, and there is a square, so this square should be with 11 and again this square should be with 10. So 11 square is 121, 10 square is 100. Now we know that if there are two zeros, we can count from the left and we can place a decimal here. So the answer would be same. Similarly here also, if you want to square 0.4 square, so we can say 4 square is 16, and now we can count 2 decimal because this is 0.4 multiplied with 0.4. So there would be 2 decimal, and we can count from the left hand, right hand side 2 decimal, and we can place here. So this would be the answer for this question. Now again we have to use the same identity here, which is a plus b multiplied with a minus b, and this is equals to a square minus b square. Now this is our a plus b and this is our a minus b. But here the minus is in the first place. So we can reverse it. So this expression can also be written as b square plus a square, and this can be written as b square minus a square. So I just have converted, or you can say I just have replaced these two terms with each other. So this can also be written. There would be no change in the sign. The sign will remain same. Now I have converted this into this form. This is a plus b. Our a here is b square and our b here is a square. And so our a here is b square and our b here is a square. So this is a plus b and this is our a minus b. And we know that a plus b into a minus b is equals to a square minus b square. And our a is, so this is our a, so this would be a square minus our b is this, and this would be b square. Now we can solve this. We know that whenever the terms are like this, the power gets multiplied. So this would be b raised to power 4. Similarly here answer would be a raised to power 4. So this would be the answer here. Now similarly here also we can use the same formula, which is a plus b into a minus b, and this is equals to a square minus b square. So this expression is same as this. This is a minus b, this multiplied with a plus b. So this won't make any change if I multiply this with this or if I multiply this with this. The result will be same. So this is same as this. Here our a is 6x and our b is 7. So we know that whenever the formula is a plus b into a minus b, this is equal to a square minus b square. So we have a minus b, a plus b, this should be equals to a square, which is 6x minus b square, which is 7. So this would be 7 square. Now if this is 6x square, this means 6 square multiplied with x square. 6 square means 6 into 6, which is 36, and x square means x multiplied with x, which is again x square, and 7 square is 49. So this would be the answer here. So this is how you can solve these questions. Thank you.